Hey everyone, and welcome to our global field trip. I'm absolutely thrilled to have you here today. Think of me as your guide, or, maybe your slightly overenthusiastic earth science teacher, because today we're using NASA's actual real-time data as our virtual classroom. So get comfortable, clear your desk of distractions, and get ready to look at our planet from an entirely new perspective. What we're doing in today's explainer is unpacking some really dynamic earth science concepts. The goal here is simple, really. We're taking complex, high-level satellite data and transforming it into a straightforward global field trip that's super easy to grasp. We're going to see exactly how the world breathes, how it shifts, and how it grows, and we're doing it all through the lens of instruments floating miles and miles above our heads.
Okay, let's just dive right into this. Our primary tool for today's lesson is NASA's Earth Observatory. Now, if you're unfamiliar with it, it's an absolutely magnificent resource. It's essentially NASA's way of bringing the Earth to you every single day. It curates the images, the stories, and the hard scientific discoveries about our environment, our Earth systems, and our climate that come directly from NASA research. It's basically how we translate raw space data into the story of our home.
So, here is our lesson plan for today. We're making 3 stops. Station 1 is land, focusing on Guadalajara. Station 2 is air, tracking changes over the northeast U.S. And Station 3 is ice, way down in Patagonia.
All right, let's get started with station number 1, land, and specifically Guadalajara's urban expansion.
We usually think of geology as moving at this agonizingly slow snail's pace, right? But human activity? We can reshape the very ground we walk on in just a matter of decades. Before we look at the actual satellite evidence, let's just make sure we ground the concept and define our terms plainly. Urban expansion is exactly what it sounds like. It's the outward spread of a city's metropolitan area across a landscape as the population grows over time. When a city can't just build up anymore, it builds out. It paves over the natural landscape, pushing its borders further and further into the surrounding geography.
Now, what's really interesting about this is the super relatable timeline we're using to measure this growth. We're looking at Guadalajara, Mexico. Our baseline year is 1986, which, fun fact, happens to be the last time the city hosted FIFA World Cup matches. Then we compare that to 2026, the current World Cup era. Over the span of just those 40 years, the satellite imagery reveals this massive westward expansion of the metropolitan area. The urban sprawl has quite literally swallowed the surrounding terrain. It's a stark, completely undeniable visual of just how rapidly our human footprint grows and permanently alters the Earth's surface.
Moving right along to Station 2, air, tracking pollution over the northeast U.S.
Okay, so we've seen how humanity changes the solid ground. Now let's look up from the land and into our invisible atmosphere. Our atmosphere is completely full of complex chemical cycles happening every single day right over our heads. We're going to break down 2 key compounds the satellites are measuring. First up is nitrogen dioxide. This is largely a morning emission. Think of millions of cars starting up for the morning rush hour, or factories powering on for the day. Once that nitrogen dioxide is up in the air, it actually reacts chemically under the sunlight to help create ozone later in the afternoon.
And this brilliantly illustrates what scientists observed using the TEMPO mission over the really densely populated New York to Washington corridor. They captured what we can call the daily pulse of air pollution. Think of it as a 2-step process. Step 1 happens in the morning. The whole region wakes up and nitrogen dioxide builds up over the cities. Step 2 happens in the afternoon. That morning pollution has chemically reacted, creating a thick layer of afternoon ozone. It is literally like watching a heartbeat. A daily A to B pollution cycle where the atmosphere breathes in emissions in the morning and exhales ozone in the afternoon. It's completely invisible when you're standing on the ground, but it is crystal clear from space.
All right, final stop. Station 3, ice, exploring glacial retreat in Patagonia. So we're leaving the urban skies of the Northeast behind and exploring the freezing extremes of the cryosphere. Listen to this dramatic observation from the Earth Observatory about Tyndall's Trail of Bergs. I want to read it exactly as they reported it. Ice splintered off the southern Patagonia glacier and drifted across a growing glacial lake. Wow. When we think of glaciers, we so often think of them as these permanent, static mountains of white, right? But this quote brings the dynamic, active movement of ice right to life. It splinters, it drifts. It's a system in intense flux.
To fully understand that imagery, we need our final vocabulary word of the day, glacial lake. A glacial lake is a huge body of water that originates directly from the melting of a glacier. As the ice melts and the glacier retreats backward, the lake fills that void and just keeps growing larger. So when we read about ice splintering off and drifting across a growing glacial lake, we're visualizing a glacier literally breaking apart into the very waters created by its own melting. It's a profound, undeniable visual indicator of warming temperatures.
So the crucial point here is, how does this all tie together, and why does any of this actually matter to us? Let's quickly review. Our land station showed us the physical footprint of human growth expanding westward in Guadalajara over 40 years. Our air station revealed that invisible, daily chemical cycle of pollution breathing in and out of the Northeast Corridor. And our ice station highlighted shifting global temperatures through the retreating, splintering glaciers of Patagonia. Taken together, these aren't just isolated events happening in a vacuum. They prove that Earth's interconnected systems are constantly shifting, reacting, and changing all around us.
Okay, Section 4. Your turn. It's time for the Satellite Puzzler.
Now, as I promised earlier, you don't get to leave this classroom without a little bit of fun homework. It's time for a pop quiz to test those newly sharpened observation skills of yours. Every single month, the Earth Observatory puts out a challenge, and I am passing the June 2026 Satellite Puzzler directly on to you. Your mission is to look at the unlabeled satellite imagery provided by NASA, guess the location somewhere on Earth, and figure out why it's scientifically interesting. I highly encourage you to put your detective hat on for this one. Our planet is vast, and the satellites are watching it change by the minute. Because think about it, if the ice of Patagonia and the air above our cities can transform so drastically in a single lifetime, what invisible changes are happening right in your own backyard right now? Until next time, keep looking down to understand the big picture.